Hi everyone, and now we're going to talk about dividing fractions. We've been multiplying them, but it's time to divide. So you should all know what this is. To divide a fraction, you pause for a second and just kind of slowly see if you can figure this out. Multiply by the reciprocal. So in essence, we've done this when we do 7/4 divided by 3/8. I can actually take that and change that to be 7/4 times 8/3 and multiply that through, canceling the 4 and the 8 to give us 14/3. If you're at this point, I want you at the top of your page to write junior. You'll see why later. Just write junior. Okay. Now with number 1, I'm just going to start by changing this division symbol into multiplication. So rewrite the problem, 2p over q times 5q over 8p. Looking at what we have now, I'm going to take this extra step in this first one just to remind you of what you do here. We're going to extend the fraction bar, and I'm going to write this as 2p times 5q over q times 8p. Because really that's what it means when we multiply fractions. Now, we don't need to do that step, but it's here anyway. Let's cancel the 2 and the 8 to give us 1 and 4. Cancel the p's, cancel the q's, and we end up with 5 over 4. No variables, but that's our final answer. Right here, I want to point out something that I saw in the test. This was something that I thought was a little bit more rudimentary. If I had something like 7x squared or 7 plus x squared h plus h, and I factored out the greatest common factor. So a lot of people writing h and then something like 7x squared, but forgetting that was x squared plus 1. This is important in this lesson because when you divide a number by itself, you get 1 and not 0. So let's just kind of keep that in the back of our minds. That's just like an extra problem there. Okay, let's go back to number 2. When we factor by greatest common factor first. So I'm going to factor and pull out a 5, and I have t minus 2 over, maybe t minus 5. Then we're going to change this to a multiplication, flip it, and I get 2 over t minus 2. A few things I'm going to do, just to be careful, I'm going to put any binomial inside parentheses, so I'd be sure that it cancels the whole thing. I'm also going to check to see that we don't have restrictions. So this is divide, give your answer in simplest form. It doesn't strictly say anything about restrictions, so I'm going to say, just for practice purposes here, let's give restrictions with one variable. When there's one variable in the problem, let's give our restrictions, just to be clear. So if I cancel the t minus 2's, t minus 5, right here I also have to say t is not equal to 5 or 2, because those are the two values that would make our denominators equal to 0. That actually occurred here and here. But then we go back to the problem and we say, okay, 5 times 2 is 10. That's going to be over the remaining t minus 5, and that's done. Number 3, we're going to want to factor everything and flip the fraction. So be really careful again that you make sure you do both things. So I'm going to factor this numerator as y plus 5 and y minus 2. I'm going to factor the denominator as the difference of two squares, y minus 4 and y plus 4. I'm going to multiply, which means I'm going to flip, and I'm going to change the other fraction to be y plus 4 over, putting that in parentheses. And then I'm going to take this and bring it down and take out a greatest common factor, take out a 2, and end up with y minus 2. Now we play the canceling game. Before that, we have one variable. We're going to play the domain game. Y cannot be. Take a look at your denominator values. We have this, this, and this. So y cannot be positive or negative 4 or positive 2. Then we can cancel. The y minus 2's go, the y plus 4's go, and I end up with y plus 5 over y minus 4. I'm going to bring that in here and say y cannot be plus minus 4 or 2. Going to number 4, we want to cancel again, or sorry, factor first. So I'm going to factor this as 2x. And let's see, we want to get to 11, so I know this is going to be 2x and x with a minus minus. 4 times 2 is 8, plus 3 is 11. over, take out a greatest common factor, can take out a 9, and end up with 3 minus 2x. Like this multiplication, flip this fraction, take out a greatest common factor, so 6x. I'm going to end up with an x squared minus, that would be 16, over, and I have x squared times x plus 4. Okay, I'm going to rewrite this all one more time for a couple of reasons. I first have to factor this out, and I'm actually going to take this and factor a negative out so that I can change its order and make it match. So watch how I do this. The numerator I'm going to rewrite exactly the same. The denominator I'm going to make a negative 9, which changes the order and makes that 2x minus 3. The numerator I'm going to keep 6x, but I'm going to change that to x minus 4 and x plus 4. Denominator, I have an x squared, then an x plus 4. We only have one variable, so we want to stay domain restrictions. Let's look at just the denominator. So I'm going to highlight again in yellow. This, and this are the parts that have x's in them. I know that x cannot be equal to, this would be 3 over 2. Then we have 0, and then negative 4. Those are our three values that come from those three highlights. Cancel identical factors. The 2x minus 3's go, the x plus 4's go, and an x goes with one of the x from the x squared. We also have a 6 and a 9 that becomes a 2 and a 3. We still have a negative 1 down there. So let's look at the numerator and group what we have. We have a 2, x minus 4 and x minus 4 makes it x minus 4 squared over negative 3, and then all I'm left with is an x. So that's an acceptable way to leave it. If I want to kind of make it a little bit more clean and pretty, I'd probably put the negative 2 on top and leave it like this, all over 3x. Either one of those are fine, along with the domain restriction. So I'm actually going to circle it like this just to give one answer. Number 5 is an order of operations problem. I'm first going to rewrite, and remember we do multiplication division left to right, so the 1/2 times 5 over 1 happens, and then 3 over 4 stays. So if I do this, now I can cancel, but I don't see anywhere I can, so 5 times 3 is 15, 4 times 2 is 8, I end up with 15/8. Number 6, order of operations says to look inside the grouping symbols first, so I'm going to make this still a division and make this 3 over 20, then it's going to become 1/2 times 20 over 3. Now I can cancel, the 2 and the 20 become 1 and 10, I end up with 10/3. So very different problems with 5 and 6, depending on what the grouping symbols are. The next one, which is, I believe, the last one, is a massive factoring one with one division symbol, which just means that the thing that follows is going to flip. So we're going to factor the b squared plus 6b minus 7 into b plus 7 and b minus 1. Going to factor denominator, no greatest common factor, and I'm going for 7, so let's change that to 3b and 2b. 20, I can do, let's see, I can do 5 and 4. 5 times 3 is 15, and 4 times 2 is 8, and that differs by 7, so I'm going to want it to be negative 15 and positive 8. That was a lucky guess, because that's a lot of trial and error, but as we keep moving on, watch how we can use that to our advantage. The next factoring is going to be this one here, and we're going to make that 2b and b. I know it's going to be a plus minus, so let's try 15 and 3. If I make it 3 here and 5, or 5 and 3, I mean 3 here and 5, that's going to be positive 6 and negative 5. Notice how these two match. It's kind of a good sign. Okay, then we got b plus 3 and b minus 1. Lastly, this is important to keep in check. This is now going to become this numerator, which I'm going to write as 3b and b. Let's do 2 here and 4 here with a minus on the 6 and the positive on the 4. That also makes this and this match, which is again pretty good. Doesn't always have to work out that way, but here it does. And then I'm going to take the numerator right here and write that down here as the denominator, because again I turned that to multiplication. So that is b plus 7 and b minus 2. So all of that factored, let's go back and state restrictions. If I look at the restrictions, I've got all these denominator values to worry about. And that's a lot of them. That means b cannot be equal to, if we read it from left to right, it's going to give us negative 4/3, positive 5/2, negative 3, positive 1, negative 7, and positive 2. All those b values can't be true. Again, that's reading left to right with all the different ones. I'll show you how they kind of match up to where they come from. So, then we're going to cancel. The b plus 7s go, the b minus 1s go, the 2b minus 5s go, the b plus 3s go. Let's see, the 3b plus 4s go, and the b minus 2s go. Don't put 0 when you divide something by itself. You get the number 1. So our canceled version is just the number 1 equals 1, and all of this stuff. Again, this is equals 1. So this would be our final answer, 1, where b cannot equal all that stuff. Your homework is listed right there, and that's it. If you've reached the end of this, what I want you to do is write down here, mint. Do not tell anyone the words you just wrote. I will be checking those.